So hello everyone, welcome to the channel. So in this video I'm going to show you the build-up area detection using Sentinel-2A Imagery and export as a Shapefile and CSV using Earth Engine. So now let's get started. So the study detects and quantifying the build-up areas using Sentinel-2A Imagery within Earth Engine and specifically focus on urban and developed land cover classification through a spectral index analysis and geospatial processing techniques. So the methodology begin by defining our region of interest, followed by the acquisition of cloud-free Sentinel-2A imagery through temporal filtering and applying the median composite to create a representative base image for the target year of 2024. So the core analytical approach utilizes the Normalized Difference Built-up Index calculated from the normalized difference between the short-wave infrared and the near-infrared spectral band, which effectively distinguish the impervious surfaces from other land cover types based on the unique spectral reflectance characteristics through the application of the calibrated NDBI threshold value. So the continuous spectral index is converted into a binary classification mask where the pixel exceeding the threshold are identified as the build-up areas, subsequently undergoing a sophisticated vectorization process that transforms the raster pixels into a polygon feature while implementing the geometric simplification and validation to ensure the topological correctness. So the final output includes a comprehensive geospatial data product compressing of a polygon shapefile containing the vector boundaries of the detected build-up areas with associated attribute data including the calculated area metrics in both square meters and square kilometers alongside the complementary CSV format summary table, providing a quantitative measurement of an urban extent for further analysis and visualization. So now let me get back to our Earth Engine. So to detect the build-up area detection using Sentinel-2A Imagery, so first we have to define our region of interest. So to create a region of interest, navigate to a suitable study region of your choice and navigate to this option called draw a rectangle. And once you click this option, you have to draw a rectangle over your suitable region of your choice. So once you created your rectangle, I'm going to click this option called exceed and I'm going to click this option and we're going to navigate to the top section here. I'm going to click it as show generated code. And here I'm going to copy the latitude and longitude of our newly created study region. I'm going to copy using Ctrl C. So once you copied it, so I'm going to close this. So I'm going to navigate to this variable called study area polygon. I'm going to paste my latitude and longitude inside this variable called study polygon using Ctrl V. So once you pasted your latitude and longitude of a newly created study region, so next step, basically we have imported our study region. So we're going to create a variable study polygon is equals to earthengine.geometry.polygon. So basically all this latitude and longitude is going to be converted into a polygon using this particular function called earthengine.geometry.polygon. So in the next step, we're going to fix our period of analysis. For example, I'm going to specifically look the build-up areas on this particular year, 2024. So we're going to fix the time range starting from 2024 January 1 to 2024 December 31st. So to do that, we're going to mention a variable called start date is equals to 2024 January 1 and we're going to fix the end period of our analysis, that is variable end date is equals to 2024 December 31st. So in the next step, we're going to set the threshold for NDBI. And basically this NDBI threshold value used to vary from 0.15 to 0.3 based on your study region of your choice. So for my current study region, this is my suitable threshold to extract only the build-up areas. So I will show you in the later steps where how to set a suitable value. So the next step, basically I'm going to mention the export setting options here. So when you're going to export this particular the build-up area as a polygon as well as a CSV file, so we're going to mention the variable export folder is equals to Earth Engine build-up exports, and similarly I'm going to mention another variable called export shapefile name is equals to build-up polygon 2024. And similarly I'm going to mention another variable called export CSV name as a build-up area table 2024. And the next step, we're gonna add our study region and center the layer. So to do that, we're gonna mention map.center object study polygon with a suitable zoom level of our choice, And the next step, I'm going to add this layer using map.addLayer study polygon with a suitable color of our choice for our region of interest, and we're going to output as a study area. So in my first step, I'm going to run this code and let us visualize the result. So we're going to close this here, and we're going to run this code and let us visualize the result. So you can able to see our study region. So this is my study region of my choice here. Let me turn to a satellite mode here, and you can able to see this study region. So once we fixed our region of interest, in the next step, I'm going to load my Sentinel-2A, the surface reflectance imagery, and we're going to apply some filter function and we're going to mask the cloud and build a median composite image for the year 2024. So to do that, first I'm going to define a variable Sentinel-2A collection equals to, so this is the variable I have defined, Sentinel-2A collection equals to earth-engine.image collection Copernicus S2 SR harmonized. So let us talk about the Sentinel-2A imagery. So the dataset availability is from 2017 to 2025, and the dataset provider is European Union ESA Copernicus. And using this particular code, you can access this dataset here, and this is a short description about this data. So after 2022, the Sentinel-2 scenes with a processing baseline of 4.0 or above have the DN range shifted by 1000. The harmonized collection shift data in the newer scenes to be in the same range as the older scenes. And Sentinel-2 is a wide swath high resolution multispectral imaging mission supporting the Copernicus land monitoring studies, including the monitoring of vegetation, soil and water cover, as well as the observations in inland waterways and coastal areas. So you can go through the description about this data. I'm going to navigate to the band section here. So in the band section, you can able to see the spatial resolution of this band here. For example, the blue, green and red band has a spatial resolution of around 10 meters, and the NIR band also has a spatial resolution of 10 meters, and other bands like red edge 2, red edge 3 and red edge 4 has a resolution of 20 meters, and the shortwave infrared band 1 and 2 has a resolution of 20 meters. And last is this aerosol optical thickness has a spatial resolution of around 10 meters. So you can go through the other band that is available here. So now let me navigate to my Earth Engine. So once you access the image using this particular code, in the next set we're going to apply some filter function in order to filter based on our region of interest. So to do that, I'm going to mention dot filter bounds based on our study area. So this is our study region, and we're going to apply the filter based on our time frame of our analysis. So to do that, I'm going to mention dot filter date, start date and end date. The start date we have previously mentioned as 2024 January 1. Let me show you that. This is the start date and this is the end date. So I have specified this particular date, start and end date. And the next step, I'm going to filter with the image with the least cloud contamination. So to do that, I'm going to mention dot filter earth engine dot filter dot lesser than the cloud pixel percentage of 10%. So we're going to specifying the condition where the cloud pixel percentage is less than 10. So in the next step, in order to acquire a median composite image out of this entire time period of from January to December, so acquire single median composite image of Sentinel-2A. So we're going to use this median function in order to get that. So for that, we're going to mention a variable S2 median is equals to S2 collection dot median function. So basically be applying a median function. So in order to acquire median's image out of this entire year from January to December, and we're going to clip it based on our study region, that is study polygon, using this particular function called dot clip function. And in the next step, we're going to visualize the image in the true color composite. So to visualize it in a true color composite, we're going to mention map.addLayer S2 median, so referring to this particular variable S2 median. And these are the following bands we're going to use in order to visualize the image in true color composite. So we're going to use the B4, B3 and B2, so which represents the true color composite image. So B4 represents red, B3 is green and B2 is blue, which going to represent as a true color composite image. And the minimum of 0 and the maximum 3000 are going to mention as the minimum and maximum value, the brightness and the contrast of the image. And the next is we're going to mention the output as a S2 median true color. So now let us take a look at this image here. So we're going to navigate to the layer and I'm going to turn on S2 median true color. So now we're going to visualize the Sentinel-2A Imagery in true color composite. So you can able to see the study region. So this is our generated image here. You can able to see it now more clearly. So you can able to see the different you can able to see the build-up areas here. So the industries and the large build-up areas are clearly highlighted in white, and small household areas are indicated in the green set of patches here, white and green patches. And we're going to navigate the layer, and I'm going to click this option, and in that I'm going to select this custom to stretch 90%, and I'm going to click apply here. So basically it's improved the contrast and the brightness of the image here compared to the previous stretch type here. So we're going to close this. So in the next step, I'm going to compute normalized difference build-up index. So to compute that normalized difference build-up index, I'm going to mention another variable called NDBI, that is normalized difference build-up index, equals to S2 median. So basically I'm referring to the median composite image right now. So we are referring to this particular variable where it holds the median composite of Sentinel-2A image of for the year 2024. And in that I'm going to apply the formula that is normalized difference B11 B8. So which represents B11 minus B8 divided by B11 plus B8. And we're going to rename as NDBI, normalized difference build-up index. So we are using these two bands, short wave infrared band and NIR, that is a near infrared band. So B11 and B8. So the next step, we're going to add this layer using map.add-layer NDBI with a minimum of minus 0.5 and to the maximum of 0.6. And the color palettes, it's going to start with blue, white and orange and red. So red, which going to represent red and orange, it's going to represent the build-up areas, and the blue, it's going to represent non-build-up or vegetation areas. And we can output that as a NDBI. So now let us take a look at this. So we're going to navigate to the layer section. Once you run the code, we're going to navigate to the layers, and I'm going to select this particular layer called NDBI. So it's going to load the NDBI. So you can able to see from this image here, we have a different contrast set of colors. For example, starting with the blue and orange, red and white areas. So the blue basically which represents the waterways in the study region. So the dark blue one here you can able to see, and the light blue one which indicates the vegetation areas in the study region. For example, I'm going to turn to a satellite mode here, and I'm going to turn off all of the layers, and for example I'm going to now zoom into this part of the study region, and you can able to see from this image here all the blue areas, the light blue areas which indicates the vegetation areas, and all the white areas. So let me navigate the layer. I'm gonna adjust the transparency here, so you can able to see all the white areas which indicates kind of looks like a barren land here, barren pathway. You can able to see this, probably a road which indicated here. So let me turn to so you can able to see that here. So it's probably the road you can able to see, and it's not a metallic road. You can able to see that it's kind of a sandy road. You can able to see from this image, from this base image here. And similarly the white patches here, so let me navigate the white patches here. So you can able to see these white patches which indicates it is a kind of an let me turn this off. So basically it is without any vegetations are highlighted in this set of white patches. So let me turn this on, and similarly I'm going to take a look at some other part of the study area. For example, I'm going to navigate here, so you can able to see this. So it looks like a kind of a farmland. So it looks like a kind of a fallow land. You can able to see from this base image here, or the exposed soil. So let us we're gonna use some inspector tool here. For example, I'm gonna use my inspect tool, and I'm gonna turn on the NDBI, and I'm gonna click it here. So let us visualize the values of this particular NDBI value, so which is around minus 0.11. So I can able to see we shall see the difference between the build-up versus the other areas. So in the next step, we're gonna navigate some build-up areas here. So all the red areas here which clearly indicates the build-up ones. So for example, I'm gonna place my inspector tool over this particular and let us take a look at the values here. So the values are clearly which indicates so it indicates minus 0.0087. So we're gonna click here and take a look at the values here. So it indicates NDBI value of around 0.19, so it is a positive value. And similarly, I'm gonna navigate to this part of the area, and it looks like a kind of build-up area you can able to see. And I'm gonna place my inspector tool over this part of the area. So I'm gonna place my inspector tool, and you can able to see the value, which is around 0.33. And similarly, I'm gonna navigate to another build-up areas. So you can able to see this is another build-up area. So I'm gonna place my inspector tool, and I'm gonna visualize the value it's showing. So I can able to see it's showing a value of around 0.22, which is a positive value. And similarly, we're gonna move on to other areas here. So for example, I'm gonna navigate this particular one. So it's basically household build-up areas compared to the commercial areas. So we're gonna navigate here. So for example, I'm gonna select this particular building. So this particular house here. So I'm gonna place my inspector tool and over this study area. So we're gonna place it, and let us visualize the result. So the value of around 0.177. So you can able to see the value. All the build-up areas are indicated in a positive value here. So based on this inspector tool, so we're gonna set the value of the threshold value of this particular study area to be around if a value greater than 0.01. So it's gonna indicate the build-up areas. So I'm applying the threshold based on the inspector tool. So from our study region. So based on that, I'm applying this particular value 0.01. So once you fix the threshold value, so the next step, so we're gonna apply this threshold to extract the build-up mask. So to do that, I'm gonna mention a variable called build mask raw equals to NDBI dot greater than the NDBI threshold. So I fixed my threshold to be around 0.01, positive 0.01, and we're gonna rename as build. And the next step, we're gonna visualize the preliminary build mask. So to do that, I'm gonna mention mask map dot add layer, build mask raw dot update mask, build mask raw, and the color palettes I'm gonna mention is yellow, and I'm gonna output as a build raw mask. So I'm gonna run this code. So I'm gonna run this code here, and let us visualize the result. I'm gonna navigate to the layer, and let me turn to a satellite mode, and I'm gonna turn on this build raw. Now let us take a look at this value here. So it's loading the data. So you can able to see here it's loaded the data. So you can able to see all the yellow areas, which highlights the build areas here in this study region. For example, I'm gonna navigate to this part of the areas. So you can able to see from this the build mask layer. So it's clearly extracted all the build up areas in the study region. So you can able to say I'm gonna zoom in here. So you can able to see it's basically it's highlighted all the build areas in yellow. You can able to see. So it also missed a few spots here. So you can able to see that it might be due to the resolution of this image. So it is around only a 10 meter of resolutions. So but it gave the output is a kind of good here. So it has extracted all the build up areas. You can able to see from this result. So in the next step, I'm gonna convert this raster. So currently it is in raster. So we're gonna convert to a vector. So to do that, to convert from raster mask to a vector polygon, so we're gonna use the reduce to region function. So for that, I'm gonna mention a variable vectors equals to build mask raw dot self mask function dot reduce to vector. So it's gonna convert it to a raster to a vector polygon. So we're going to mention the geometry to be study polygon, and the scale is 10 meters, and the geometry type is polygon, and the label property you're going to mention is build val, and the max pixel value is 1:10 power, and the tile scale I'm going to mention is 4. And in the next step, we're going to clean and simplify the polygon and fix the invalid geometries and compute the area. So to do that, I'm going to mention the variable save polygons equals to vector dot map function So we're gonna apply, we set a small simplification and fix the geometry via buffer. So we're gonna mention the variable geometry equals to earth engine dot geometry f dot geometry dot buffer. So from 0 to 10. So buffer 0 often fixes the self intersection with a maximum error of around 10 meters. So in the next step, I'm gonna mention geometry equals to geometry dot simplify 5. So we're gonna simplify with the 5 meter tolerance. And the next step, we're gonna mention the variable area meter square. So we're gonna we're gonna compute the area. So for that, we're gonna mention variable area meter square is equal to geometry dot area, and the max error is 100. And we're gonna return as earth engine dot feature geometry, and the build val we're gonna mention is f dot get build val, and area in meter square we're gonna mention area in meter square and area in square meters. So to convert from meter to square meters, we're gonna mention is earth engine dot number area meter square dot divided by 1:10 power 6. So it's gonna convert the meter square to kilometer square. So for that, we're applying this. And the next step, we're going to print the total and sample feature. So to compute the total build-up areas in the region of our interest, we're going to mention another variable, total build area in square kilometers equals to save polygon dot aggregate sum. So we're going to mention area in kilometers square. So last, we're going to mention is print total build-up area in square kilometers within our study region, referring to this particular variable, the total build areas kilometers square. And to print a sample polygon attributes for first 10 values, I'm going to mention print build up polygons filtered save polygons dot I'm going to mention a function called dot limit 10. So now let us visualize the result. And last, we're going to apply this polygon. So to add this vector polygon, I'm going to mention is map dot add layer save polygon dot style. The color, I'm going to mention the color to be in red, and the fill color, it's going to be f 000022, and the width I'm going to mention is 1, and with the default visualization parameter, and we're going to output as build up polygons. So now let us run this code and visualize the result here. And going to navigate to the console section here. So in the console section, it's going to compute the total build up area in square kilometers. And in the layer section, I'm going to turn on this satellite mode, and I'm going to turn on the build up polygons. So it's going to load the polygon, that is a vector polygons. So I can able to see it is loading the polygons here inside our region of interest. So now I can able to see this is our build-up areas. So I can able to see from this. So let me show you inside our study region. So it managed to give us all the build-up areas in our study region. You can able to clearly visualize it. And also it's calculated the total build-up area in the study region in square kilometers, which is around 27.33 square kilometers of area of build-up in the study region. So in the next step, and let me show you without the satellite image. So now you can able to see the build-up areas more clearly. So in the next step, we're going to export this polygon, export this particular build-up area as a polygon as well as a CSV to our Google Drive. So to do that, I'm going to mention export polygon. So to do that, I'm going to mention export.table.drive. Collection, I'm going to mention is save polygons, and the description is export shape names, and the folder I'm going to mention as export folders, and the file name prefix is export shapefile names, and the file format is in shapefile. And similarly, to export as a CSV of attributes, you're going to mention export.table.toDrive, and the collection I'm going to mention is save polygon, and I'm going to select area in square kilometers. And the description I'm going to mention export CSV name, and the folder is export folders. And the file name prefix is export CSV name, and the file format is CSV. So we're going to run this code, and once you run this code, we're going to navigate to the task section here. And in that, we have this two tasks called unsubmitted task called the build up polygons and the build up area table 2024. So we're gonna click this option called run, and I'm gonna select. You're gonna able to see that we're gonna export to our drive, and the drive folder is Earth Engine build-up exports, and the file name is build-up polygon, and it is in Shapefile. So to export this particular polygon to our Google Drive, I'm gonna click this option called run. So once we're gonna click this option run, so it's gonna start exporting our the build-up polygons to our Google Drive. And similarly, to export our build-up area table 2024 CSV, so we're gonna run this code called run, and it's gonna export to drive, and the file format is CSV, and we're gonna click run to export this particular file to our Google Drive as a CSV file format. So now here the build-up area, the CSV has exported, which took less than a minute to export. So similarly, it's taking some time to export the build-up polygons to our Google Drive. So now it's exported the build-up polygon to our Google Drive. So it took around 5 minutes to export this particular the build-up polygon to our Google Drive. So in this video, I have shown you so the build-up area detection using Sentinel-2A Imagery and export as a Shapefile and CSV to our Google Drive in Earth Engine using Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like.